Hi, my name is Robin, and today I'm here to talk about Predictive Insights Engine, or PI, a project which I did for class 1125 at MIT. When you think about a data center, you probably picture a bunch of servers on racks in a room. But when you take a closer look, you'll see that there are a lot more components that goes into making a data center. You'd have the network layer, then you have the storage layer where you would save all your files and data. Then you have your servers, which responds to the requests that are coming in. On top of that, you have all the operational stuff, security layers, um, and other things. So basically, all this is encapsulated by the cloud operating system, which provides an interface for your applications to talk to the data center and other layers beneath it. So with all these components in place, issues are bound to happen. With the whole revolution around cloud computing, big data is a thing of the present. You have petabytes of data flowing through these pipelines, and there's a big surge in the demands for services and applications that have 99.9999% uptime. So that leaves DevOps and IT teams with a very little response time, and they have to resolve the issues quickly to get the service up and running. Service impacts directly affect revenue in most cases, and besides that, performance is equally important when it comes to user experience, as and a responsive application will adversely affect user retention, which again affects revenue. So with all that in mind, you have to have high availability for a data center. You got to have performance at scale. It has to offer instant scalability. Uh, running it successfully is a lot more difficult task. So with all these different components, how do you go about making sure that it actually is up and running? So there are monitoring solutions out there which does the round the clock monitoring for you, and which then connects to other devices like SMS, PagerDuty, dashboards, alerting, and other alerting mechanism. But sometimes that is just not enough. Real-time monitoring solutions are very helpful. It is actually a prerequisite for doing successful predictive analysis, because without monitoring, we won't have the required data to make appropriate decisions. However, it has its limitations. Continuously monitoring and remediation can be challenging at times, since operation team are on very tight schedules when it comes to resolving any issues. This makes prediction a key success factor in cloud environments. Uh, PI's approach is to use up your historical data and make educated guesses about the future. By putting all this historical data into perspective, you can generate estimates for what might come up in the future and what you need to do to sustain the growth of your customer base. Let's talk about the architecture of Pi. This whole thing is deployed on a Mesos cluster. For my experiment, I have deployed a 50-node Mesos cluster which has monitoring agents running on them, which reports the disk usage percentage of the node every couple of minutes. Data collection is the first step of the solution. Once the data is collected, it's pushed into an Elasticsearch cluster, which which is the data store we are using in this case. Once the data has been pushed, we have a Spark cluster running, which has master and slave nodes, and to run the analysis, it pulls the data from the Elasticsearch cluster and runs the Pi engine, which then does the prediction on the data. Once the prediction is done, the third step is to write that result to a database. In this case, we are using a SQL-backed data store. And using this data, using this persistent data, we can then have a visualization on top of it using any of the open source tools like Grafana or Kibana, which could then project the data.